In your last video, you learned about the arrangement of the periodic table and how it is placed in rows, which we call periods, and columns, which we call groups. In this video, we will be looking again at valence electrons as well as trends that we can see as we look on the periodic table. So, to review valence electrons, these are electrons that are located in the outermost shell. You can figure out the number of valence electrons a group has based on its number. So an element in group 1 is going to have 1 valence electron. Group 2 has 2 valence electrons. We skip over transition metals just because they follow a different set of rules. So then 13 has 3 valence electrons, 14 has 4, then 5, 6, 7, and 18 has 8 valence electrons. All of the elements within a group are going to have the same number of valence electrons. The exception to this rule is helium. Helium can't have 8 valence electrons because it only has 2 electrons, and both of those are considered its valence electrons. Now, you've all learned that protons determine the identity of an element, but valence electrons are important because they determine the element's reactivity, or how the atoms interact with each other. When you're thinking about reactivity and valence electrons, one thing to remember is that atoms want full shells. So normally anything over helium is going to have a full first shell with 2 electrons, and then it's going to have it might have a full shell, second shell with 8 electrons. If it doesn't have a full shell, an atom is going to try and give away its electrons or take electrons so that it can get completely full shells. Here are some examples. This atom needs 4 more electrons before it can have a full shell. It could either give away the 4 it has so that it has a shell of 2, or it can take 4 from a different atom. This atom usually won't react with anything because it already has its 1, 2, 3, 4, 5, 6, 7, 8 electrons, and it has a full shell. Here are some other examples. Helium probably won't react with anything because its shell is completely full. Chlorine is missing all but 1, so it's going to be really reactive since it only needs one more electron to become a full shell. Potassium is also really reactive because it only has to give away 1 electron before it has completely full shells. This concept may seem kind of difficult, but don't worry, you'll get to practice it in class. Now, in terms of periodic table trends, there are some that are fairly simple and some that kind of seem complicated. One that you probably noticed from the first moment that you looked at the periodic table was the atomic number. You should have noticed that as you move across the periodic table, the atomic number increases 3, 4, 5, 6, 7, 8, etc. As you move down the periodic table, the atomic number also increases 8, 16, 34, 52, etc. Same thing goes for atomic mass. If you move across the periodic table, the atomic mass is going to increase. If you move down the periodic table, the atomic mass is going to increase. Now, when we talk about metallic properties, we're only involving metals, since those are the ones that might have metallic properties. When you're looking at the periodic table, moving across left to right, the metallic properties actually decrease, which is why we have nonmetals over here. And as you move down the periodic table, the metallic properties increase. So as you move across, things become less metallic, and as you move down, they become more metallic within the metals. Reactivity can also be a little tricky because it switches for metals and nonmetals. For metals, reactivity decreases, so things get less reactive moving across, and increases moving down, so they get more reactive moving down. For nonmetals, reactivity increases moving across and decreases moving down. The exception to this is the noble gases because they are not reactive. So that's it. Make sure you write down that table, and if you have any questions, be sure to ask your teacher.